All right, the first thing we're going to talk about is parallel and perpendicular. Well, this whole section is about parallel and perpendicular lines. We're going to start with the formula for slope. The formula for slope is y2 minus y1 over x2 minus x1 equals m. And they have written just a general point. So let's say we take any point on the line xy with a specific point on the line x1, y1. And so my formula looks like this: y minus y1 over x minus x1 equals m. Now let's say we want to get rid of this fraction here. So if we wanted to get rid of that fraction, we can actually multiply by the group. We did this when we were doing formulas that only had variables. So we can multiply everything by this x minus x1. And what happens here then is it actually cancels down here. So this cancels with that, and I'm left with just y minus y1 equals m times x minus x1. This is a new formula for a line called your point slope. All right, so this is your point slope formula of a line. So this is another one that you are going to have to know. Point slope. And this is what you're going to use if you have a random point and the slope. Point slope. All right. And so if you had the y-intercept, well, that's easy. Then you have, the y-intercept, and you can very simply put it in slope-intercept form. Or there will be times when you have another point that is not necessarily your y-intercept, and you want to find either the standard or the slope-intercept form. And you're going to start with this point slope. And it comes from your slope formula. So in point slope, just to show you what it represents, your m, as it does in all of your formulas, that is your slope. So your m is your slope. All right? And then you will have a point, an xy point. So this xy point is where you will put it right here, x1, y1. So this x1 is the x-coordinate of your point that you have been given, and the y1 is the y-coordinate of the point that you have been given. Just like in slope-intercept, your y will stay a variable, and your x will stay a variable. So you will not use those as far as plugging a number in. This will be a variable, and this will be a variable. So it will be left as x and y. You won't plug those in with a number value. So y minus y1 equals m times x minus x1. All right? So first of all, let's just use it. All right? So let's look at example 1. Example 1 on page 256. Use the point slope formula of a linear equation to write the equation of the line that passes through these 2 points. And they want us to write it in slope-intercept and in standard form. So they want it in slope-intercept and in standard form. So with either one of those, using point slope, we actually need the slope. All right? So before we can do anything, we need to find the slope. So we're going to find the slope with our slope formula. We're going to say y2 minus y1, x2 over x2 minus x1, and we are going to solve for our slope. So our slope is going to be our y's subtracted, so 2 minus negative 4 over our x. Remember, use it the same. If that was 2, then my first x needs to be my negative 5 minus 3. All right? So on the top, I have 2 minus negative 4. What is 2 minus negative 4? 6. What is negative 5 minus 3? Negative 8. If I reduce that, that becomes negative 3/4. So my slope is negative 3/4. All right? And they want me to use the point slope. So go back to what my point slope is. My point slope is y minus y1 equals m times x minus x1. I need to use an x and a y. Now I have 2 points to choose from. You can choose either of the 2 points. It does not matter. So I will typically use the one that is the easiest to use, all right? In this case, I think you're going to end up with a fraction no matter what. So in the book, they used the 3, -4, so we'll use that one so we can follow along with that. So remember, y is a variable. I'm going to leave y as a variable. I am using the point 3, -4, and the slope that I found, all right? So I say y minus my y1, well, my y1 is -4, equals m, my m was -3/4, and then x minus my x1 was 3. You can do it with either point. You could have done it with -5, 2. You could do it with 3, -4. It doesn't matter which of the 2 points you use because they are both on the same line. It just told us that, okay? They want it in slope-intercept form. To get it in slope-intercept form, I need the y by itself. So I need to simplify some things. Y minus a -4. I can write that y plus 4. That's much easier, okay? And then I need to distribute my slope because I'm going to try to get the y by itself here, okay? So I distribute -3/4 times x is just -3/4 x. And then -3/4 times -3. -3/4 times -3, remember that's -3 over 1, is going to give me a positive 9/4. So -3/4 times -3 is positive 9/4, okay? I'm still trying to get it in slope-intercept form, which means I still need the y by itself, so I need to move the 4 over. So now I'm going to subtract that 4 over, subtract it from this side, it will cancel. That gives me a y, and I'm going to subtract it over here. Remember, it's 4 over 1. If I am subtracting 9/4 and 4 over 1, what do I need? When you subtract fractions, what do you need? Common denominator, right? What is my common denominator between 9/4 and 4 over 1? 4. So we're going to multiply top and bottom by 4 here. So I have my -3/4 x. That's going to stay the same. I have 9/4 minus 16/4. What's 9 minus 16? Or 16 minus 9 is 7, and it's negative because the 16 was larger. So -7/4. So that's -3/4 minus 7/4. This is slope-intercept, right? Everybody see that slope-intercept? Yes? Slope-intercept, all right? They also want it in standard form. We just did this at Bell Work, all right? What do I have to do to have it in standard form? My x's and y's need to be on the left-hand side, and I need to get rid of my fractions, right? So to do that, I can start right with my slope-intercept if I want to, or I could go back to the point slope if you want to. I think it's easier just to start at the slope-intercept. If I start at the slope-intercept, all right, then I am going to have to move my x's over, all right? So if I start here, I have y equals -3/4 x minus 7/4, okay? I need to move my x over to this side. So it's going to change signs. Remember, anytime you move it across the equal sign, it changes signs. So that becomes positive 3/4 x plus y equals -7/4. I also need to get rid of my fractions. So I multiply everything by my denominator. So what's my denominator here? What's my denominator? 4. So I need to multiply this by 4. I need to multiply the y by 4. And I need to multiply this side by 4. So here, my 4's cancel. I get 3x. 4 times y gives me 4y. And my denominators cancel here equals -7. So that is the standard form of this equation. So when you have a point and a slope, you can use them to solve for your equation of the line in whatever form they want. You just need to read your instructions. If it says use point slope to get slope-intercept, then you're going to use it and get y by itself. If they want standard form, you're going to use it and get your x's and y's on one side and your numbers on the other. question. So when we think about parallel lines from our prior knowledge, we know that parallel lines never intersect. They're on the same plane, they never intersect. They have no points in common. Perpendicular lines, they intersect exactly at 90 degrees. Exactly at 90 degrees. So what does that have to do with slope? Well, let's look at the example they have right below that. They want us to look at the slope of these three lines. These three lines are parallel lines. Line A is that blue line all the way to the right. It had a y-intercept of 0, -4. You can see that down here. It has a slope of 2. How do I know that? Well, I go up 2 and over 1. All right, look at the line B. My y-intercept here is +1. It also has a slope of 2, up 2 over 1. C is a y-intercept of +3, up 2 over 1. What do you notice about the slopes of those three lines that are parallel? They are the same, which will always be true of parallel lines. Parallel lines will have the same slope. They will have different y-intercepts. By the way, if they had the same y-intercept, it would actually be the same line, okay? So they have the same slope, different y-intercepts, all right? So anytime you have a parallel line, they will have the same exact slope. The same exact slope. So the first thing you can do is you can just, without even seeing the line itself, you can be given the equation of the line and you can figure out if they are parallel by simply figuring out what the slope is. The easiest way to figure out the slope of a line, if you have the equation, is to put it in slope-intercept form. Because in slope-intercept form, the number in front of x will be your slope. So let's look at this example 2 here. Example 2. Determine if these lines are parallel. They have 3x minus y equals 6 and -9x plus 3y equals 12. Just looking at these, we cannot tell what the slope is because they are both in standard form. So we are going to move these to be in y-intercept and slope-intercept form. So we have 3x minus y equals 6. To put this in slope-intercept form, I need to move my x over and then get rid of the number in front of y. So that becomes -y equals, remember, if it crosses the equation, it changes sign. So that becomes -3x plus 6. And then the number in front of y is -1. So divide everything by -1, which basically changes the signs. -y becomes +y, -3 becomes +3x, and +6 becomes -6. So what is my slope of this line? 3, right? It's the number in front of x once I have it in slope-intercept. Let's look at the next line. We have -9x plus 3y equals 12. All right, once again, I need to move my x over to the other side. 3y, my -9 changes signs because I have flipped it to the other side, +9x plus 12. And then I need to get rid of the number in front of y, divide everything by that. Y equals 3x plus 4. What is my slope here? What's my slope? 3. Yes, these are parallel. So these lines, so yes, they are parallel. By the way, the notation for parallel just looks like that, but they are parallel lines. All right, yes, these two lines are parallel. I know that because they have the same slope. They have the same slope, so I know that they are parallel. For this one, they just want you to tell me what the slope of a line would be if it was parallel to this line, which means you need to figure out what the slope of this line is. It says write the slope-intercept form. So first of all, when you are reading this equation, pay attention to the form it wants. Slope-intercept form. Your brain should immediately say slope-intercept is y equals mx plus b. So your final answer should be in that form, okay? It doesn't mean that when you get there, like on the way there, you're not going to use something else, but that should be your final answer, slope-intercept. Of the equation of the line parallel to 4x plus 3y equals 17 and passing through the point -5, 9. All right, so you have the point and they have given you a line parallel to it. So we're going to probably start with point slope and then solve to our slope-intercept, okay? We need the slope, however. So we have a point, we need the slope. In order to get the slope, we need that line that it is parallel to in slope-intercept form. We need the slope of that line. So we are going to start with this line right here, and we need to figure out the slope of it. So I have 4x plus 3y equals 17. To find the slope, I'm going to move my x over. 3y equals, remember it changes signs, negative 4x plus 17. And then I divide everything by 3. So this line, I just rewrote it from standard form to slope-intercept. Negative 4/3 x plus 17/3. All right? So I want a line that goes through this point, negative 5, 9. So I have the point, negative 5, 9. And it is parallel to this line. If the line that I am looking for is parallel to that line, what is the slope of the line I am looking for? If it is parallel to the line I have been given. Yeah, negative 4/3. If it is parallel, it should be the same. So now I have a point and a slope. All right, I'm going to put it in slope-intercept form. There's actually two ways to do it. If it tells you use to point slope, use your point slope. I actually find that the easiest way to do it because once you get y by itself, you're done. You could also go back to your slope-intercept and plug in your x and y and solve for b and then plug everything back in. But if you use point slope, you can distribute, move the number over, and you're done. So then what is my point slope? Well, it's the one that we have been using. Y minus y1 equals mx minus x1. They have given me my x1. They've given me my y1. I have figured out my m because it's parallel. So I just plug it in and I go. Y minus my y1 is 9 equals m. That's negative 4/3. X minus x1 is negative 5. All right. On the left-hand side, I'm going to leave that alone for right now. Minus a negative 5, that's the same thing as plus 5, right? Minus a negative, same thing as plus, all right? Distribute your m. Negative 4/3 times x, that's negative 4/3 x. Negative 4/3 times 5. Remember, that's 5 over 1. So I have negative 4/3 times 5 over 1. It gives me negative 20 over 3. All right, negative 20 over 3. My last step is to get y by itself. I need to add the 9 over. All right, so if I add that 9 over, cancels out there, I get y equals, I have to add it over here. Remember, it's 9 over 1. If I'm adding fractions, what do I have to have? Common denominator. What is my denominator between 20/3 and 9 over 1? It's just 3. So I multiply the top and bottom by 3, right? So I get negative 20 over 3 plus 27 over 3. What's negative 20 and positive 27? Yeah, just 7. So this becomes right here 7 over 3. So I have negative 4/3 x, and I simplified this part of it to 7/3. That does not look like an x. We're going to make it look like an x. Write the slope-intercept form. That is the form that I have of the line that is parallel, same slope as this guy right here, parallel and through the point 5, 9. So parallel to that, same slope, through the point this, I used point slope to start, solve for y, okay? So if it is parallel, you use the slope of the parallel line, that's all you use. You notice that I did not use the 17/3 at all. I don't need it, okay? I only need the slope from that line. And then I use the point slope and solve for y. If they want it in slope-intercept form, you just solve for y and you're done. Distribute your m, move your y1 over. Question. So if they want it parallel to that line, The first thing you have to do is find the slope of that line. Then use the slope and the point that they gave you for your point slope equation. And then solve for y. So get y by itself. They are asking for the slope-intercept line of this particular point 1. So slope-intercept is what they want. So you want it in y equals mx plus b when you're all done. So negative reciprocals of each other, flip it and negate it. And by negate, I just mean change sign, okay? All right, if it's positive, it becomes negative, negative becomes positive. So let's look at this first example. State the negative reciprocal of each number. State the negative reciprocal of each number, all right? 8/5. If I want the negative reciprocal of that, I'm going to flip it upside down, 5/8. It was positive. I am going to change it to negative. Negative reciprocal of 9. Because it's a whole number, I'm going to put 1 over it. 1/9. It was positive. It becomes negative. C, negative 13/7. I am going to flip it. 7/13. It was negative, so now that one will be positive. All right, so negative reciprocals, you just flip them and change the sign. Perpendicular lines will have slopes that are negative reciprocals of each other. So just like we use the slope on parallel lines, we're going to do the same thing with perpendicular lines. We will figure out what the slope is, but instead of just using it, we're going to flip it and negate it because we're going to be looking for a perpendicular line, not a parallel line, okay? So let's look at example 5. Write the slope-intercept form. So they want the slope-intercept form of the equation of the line that is perpendicular to y equals negative 4x plus 9 and that goes through the point 2, 7. Now for this particular example, they gave it to us in slope-intercept form. That was very nice of them, all right? So the slope of this line is going to be negative 4, right? The slope of that line is negative 4. Our line that we are looking for is perpendicular to that line, correct? So if I want the slope of my line, I need to use the negative reciprocal of negative 4. So I'm going to put 1 over, and I'm going to change the sign. So the slope of the line I am looking for is going to be positive 1/4. Flip it and change the sign. So my slope is positive 1/4 of the line I am looking for. And the point is 2, 7. So I have a point and the slope. I am going to use point slope. All right. Y minus my y1, which is 7, equals m, that is 1/4. And then x minus my x1, which is 2. I want it in slope-intercept form. Distribute your slope, move your y over, okay? Move the number that's with y over. So I'm going to distribute your 1/4 through here. So I have y minus 7, leave that alone for right now. 1/4 times x is 1/4 x. 1/4 times negative 2. 1/4 times negative 2, remember it's negative 2 over 1. You can cross cancel or you can just multiply and reduce. That's going to be negative 1/2. So not 1/5, I wrote and said negative 1/2, okay? So just pay attention to multiplying fractions. So that's going to be negative 1/4 x minus 1/2. I am not done. I need y by itself if I want it in slope-intercept form. So I need to add 7. All right. Remember, I'm adding negative 1/2 and 7. What do I need here? Common denominator. So multiply top and bottom by 2. So negative 1/2 plus 14 halves is going to give me 13 halves. So I end up with, I've already canceled my 7 over here, so I have y equals 1/4 x, and when I simplify this, negative 1/2 and 7, I get 13 halves. That is the slope-intercept form of the line that is perpendicular to this line and goes through the point 2, 7. Are these lines parallel, perpendicular, or neither? In order to answer that question, we have to know what their slopes are. All right, so this slope, move the 2x over. It's always going to be the negative of the x divided by what's in front of the y. That's always going to be your slope. So this slope is negative 2/5 x. That slope is negative 2/5. All right, negative 2/5. Move the x over. In this case, there's nothing in front of the y. My slope here is negative 4. These are not the same. These are not negative reciprocals of each other. These are neither parallel or perpendicular. They are just intersecting lines. If they had been the same, I would have had parallel lines. If they had been negative reciprocals, I could say they are perpendicular lines. These are neither. They're just two lines that intersect. All right? We know they intersect because they're not parallel, but they don't intersect at right angles because they're not perpendicular, okay? So you can just look at the equations of two lines and you can figure out if they are parallel, perpendicular, or they're just intersecting lines. They're neither. Questions? Homework.